Okay, so Leetcode practice time. So in this video there are two goals. The first goal is to see how to solve this problem. We are going to find a solution and then we are going to do some coding work. And the second goal is to see how to behave in a real interview. Suppose this is something for real in an interview. So let's get started. So remember, the first step in a real interview is always try to fully understand the problem. If there is anything unclear, please bring up the question. And also at the same time, think about some edge cases that you need to deal with, especially in the next step. So let's read through this problem. Merge k sorted lists. So you're given an array of k linked lists. Each linked list is sorted in as any other. So merge all the linked lists into one sorted linked list and return it. So for this one, you're going to return something like this. Okay, makes sense. Let's see. So k is a linked list on length, and the k is between 0 to 10,000. So what is a k? Array of k link. Okay, so it could be up to 10,000 linked lists. So the length of each list is between 0 to 500, and for each of the numbers between minus 10,000 to positive 10,000, and list I is sorted in as any other. So the sum of list I the length won't exceed 10,000. It's good to know. But one thing I want to ask is it allowed for us to change the linkage between each node? So it's the list, because yeah. So I would ask the question like, is it possible to change the linked to change the list node, is essentially the next pointer? So if yes, we can save some space. Otherwise, we need to create a new linked list. Other than that, I think we should be okay. Maybe one thing we need to think about regarding the edge case is what if there is zero number of the lists, which means k is equal to 0. Then we need to deal with it specially. So other than that, I think we should be good to go. So the next step is about finding solution. So how to find the solution? What is a possible way to solve this problem? So the first way that comes to my mind is to use a main heap to solve this problem. So we keep a main heap of size k, and every time we just pop the top element from the main heap, which is the smallest element, and append it to the end of the current merged sorted list. And each time we pop we pop a list node from the main heap, we are going to add the next element, the next element to the node we just popped out to the main heap. If we have traversed separately about one sorted list, which means we arrive at the end of one sorted list, we just don't need to add the next element into the main heap, because it is essentially a non-pointer for that. Other than that, so this one, it will give suppose the average length for each list is n, then it will give us n log k as a runtime. So other than that, I can think of, so the first one is to use min heap, and the second one I can think of is we could use a merge sort to solve this problem. So merge sort is, first of all, let's say we have several lists. Let's say L1, L2, L3, and L4. So first of all, we merge the neighbor 2 lists into one. We merge L1, L2, and L3 and L4 into, so we merge L1 and L2 into L1 and L3 and L4 into L4, and then we merge L1 and L3 together into L1. So that's so that's essentially what merge sort is. And also this is going to be all of unlock K regarding the runtime as well. So having said that, they have the same runtime. Space wise, I think merge sort is a bit better because this the main heap solution is going to take all of K because we need to keep the main heap. Otherwise, I think this should be similar regarding the efficiency. So after we find the solution, it's time for us to do some coding work. So for coding, we care about the code correctness and the readability, and of course the speed is a factor to consider. So let's take a look. So for the solution, merge K lists. So first of all, I would say if lists dot length is equal to 0, so if it is empty, then we just return a non-pointer. Otherwise, okay. So by the way, I think I just want to use a main heap to want to implement the main heap solution. So we will say, otherwise we will say main heap. Let's say priority queue. Okay, so this is list node. Let's say this is a main heap as new priority queue. So we will set this as K, and we will keep it. We will pass in a lambda. Let's say this is node 1, node 2. Return node 1 minus dot value minus node 2 dot value. Yes. Yeah, so that should be the definition of the main heap. And we are going to initialize the main heap with so for lists in the lists, we are going to have main heap dot add the list, which is the first node of everything. Okay, and main heap dot is empty. So while it is not empty, so okay, so let's first define a list node that, let's say, had is still equal new lists node. Yep. So we have the had. Well, the main heap is not a something empty, then we are trying to first pop something from it. List node is equal to main heap dot pop. It's just full. Okay. So head dot next is equal to node, and head is equal to head is equal to node. So we are going to point head. No, so it should be, so head is equal to, it's not like that. So we should say list node, let's say temp is equal to head, or just the iter is equal to head. We will say iter dot next is equal to node, and we are going to set iter as a node. And if so, we are also going. So if the node dot next is not equal to non-pointer, is not equal to a non-pointer, then we will have list node. Let's say first of all, let's say list node next is equal to non-pointer. So list node is, if node is not equal to a non-pointer, then we will set next to be node dot next. Alright, so and also we will need to set node dot next is equal to none to reset the next pointer for the node. Yes, so I think that should be it. So it is node if it's node next, so the next node is list of the node is node dot next. Next is equal to node dot next. Yes, so if next is not equal to none, then we just add it into the main heap. Add the next. Okay, so let's see. So first of all, we pop the top element from it, and then we set iter.next as node, and then we set iter as a current node. And also we get the next node from the current node we pop from the main heap. And if the next node is not a non-pointer, so if the next node is not a non-pointer, then we are going to add it into the main heap. So if next is not a non-pointer, then we are going to add it to the main heap. Yep. And we will have the node.next is equal to a none. Because this is a current node. Yep. This is a current node, and we reset the next pointer. Okay, so I think that should be it, and finally we will return head.next. So after we are done with coding, we still need to do some testing. So for testing, let's go through some simple example to see how this piece of code is gonna work, and at the same time we are going to do some sanity check about the logic. So let's see. So suppose the list is something like this. So if it is something like this, first of all we will have define the priority queue, and we go through every list, add a node into the main heap. So we are going to have 113 112 in the list in the main heap. So well, main heap is not empty, so first of all we are going to pop one from the, so this one is this. We are going to pop one from the main heap, which is this node, and we are going to say iter.next. So this is head is pointing to iter, so it's currently iter is a head, and we will set the next is equal to a 1, and so this is iter, and iter is equal to the current node. Okay, and we are going to say, okay, the next node is equal to 4, because 4 is not a non-pointer, so we are going to add 4 into the main heap, and we are going to set node.next as none, which means we are going to set 1 as none. The next time when we pop the 1 from it, we are going to do similar stuff. So we are going to say, okay, we are going to append you to the next 1, so this is another 1, and then we move the iter, and we see that the next node is 3, which is not empty, so we are going to add 3 into it, and then we are going to reset the next pointer for 1. Okay, so similarly, we should be able to finally get a linked list, and finally we return head.next, which is this pointer. So I think it should be good overall. Let's give it a shot. Okay, so before that, let's examine the edge case. So for this, so if it is empty list, then we are just going to return 0. Sorry, we are going to return non-pointer if it contains an empty list, because so first of all we add okay, so if it has an empty list, I don't think it is going to work well. So I would say if list is dot so if list is equal to non-pointer, then we are just going to continue. So if it is none, then we are just going to continue. So for this case, it will result in an empty min heap. So we are just going to return a non-pointer when after that. Yes, I think so. So let's give it a shot. Alright, so for list, oh, okay, so this is a list node. Sure, so it is a k. Okay, so the k is actually list dot length. Alright, so after fixing the typo, we are accepted. Okay, so it's accepted as well after the submission. So that's it for this coding question. If you have any question about the puzzle or about the solution, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.